So 7.5, we're going to do the same thing that we were doing yesterday in 7.4, but just kind of like turns it up a little notch. So looking at example 1. So here we have sine and cosine squared. We can't factor, David, with what we have. So sometimes we may have to use a trig identity to help us solve. We want to get all of our trig functions to be the same. Richard. So we have sine squared plus cosine squared is equal to 1. This is our trig identity. I want to replace cosine squared with something to make my trig functions the same. So I want to find what cosine squared is equal to. So I'm going to subtract sine squared. So cosine squared is equal to 1 minus sine squared. So I'm going to take the cosine squared that I have here. Isa, bless you, and replace it with 1 minus sine squared. So we have 1 plus sine is equal to 2. Now I'm taking out the cosine squared and replacing it with 1 minus sine squared. So how would I simplify this? We're going to distribute. So we have 2 minus 2 sine squared is equal to 1 plus sine. Now we have a sine squared and a sine. Just like if we had x squared and an x in an equation, how would we solve? We need a factor. So when we factor, we want to move everything to one side to get it to be equal to 0. So I'm going to subtract 2 and add 2 sine squared. So we have 2 sine squared theta plus sine theta minus 1 is equal to 0. Now, how would we factor this? Multiply the first times the last. So we get negative 2. What are 2 factors of negative 2 that add to 1? 2 and negative 1. So this would factor into sine theta plus 2 and sine theta minus 1. Now, when we multiply the first times the last, what do we have to remember to do? Divide. Don't forget to divide by the number that you multiplied. So here we get sine theta plus 1 and 2 sine theta minus 1. What would we do next? Set them equal to 0. So I'm going to do 2 steps in one. We set them equal to 0, and I'm going to solve. So sine of theta is equal to negative 1, and sine of theta is equal to 1/2.
So do we really have to move 2 in front of the side?
Not really, because when you solve, it ends up, you could divide it anyways, so you could leave it as 1/2. Question so far? Sine tells us we have to look at what on our unit circle? The y. So where on our unit circle is y negative 1? 3 pi over 2. So theta is going to equal 3 pi over 2. Anywhere else is our y negative 1? No. So let's move on to the next one. Sine again is y. Where is our y on the unit circle? 1/2. Pi over 6 and 5 pi over 6. Perfect. So those are going to be our other 2 answers. Pi over 6 and 5 pi over 6. The order doesn't matter for the answers. All right, example 3. So here we're doing the same thing. We don't have a trig identity that we can just switch one of our functions to be right off the bat. But what we can do is square both sides of our equation. So we're going to make one of our trig functions squared. That way we can replace it to be the same thing. However, with cosine plus 1 squared, how would we do that? Not factor, but FOIL. So it's like saying cosine plus 1 times cosine plus 1. So when we FOIL it out, we get cosine squared plus 2 cosine plus 1 equals sine squared. Now we want to change sine squared out with something. So let's look at our trig identities. So one of them is sine squared plus cosine squared is equal to 1. If I'm going to replace sine squared, I want to figure out what sine squared is equal to. So sine squared would be equal to, when we subtract cosine squared to the other side, it'd be 1 minus cosine squared. So we're going to take 1 minus cosine squared and plug it into the sine squared. Now we have cosine squareds and cosines, so what do you think we're going to have to do to solve? Move it to the other side so we can factor. We're going to want to factor. So let's move everything to one side to get it to be equal to 0. So I'm going to subtract 1 and add cosine squared. Yes. So 2 cosine squared plus 2 cosine. The 1's cancel, so this is equal to 0. How would we factor here? Right, we're going to take out the GCF, so we're going to take out a 2 cosine theta. When we take out a 2 cosine theta, we're left with cosine theta, what? Plus 1, perfect, is equal to 0. What do you think we could do next? Set them both equal to 0. So 2 cosine theta equals 0, and cosine theta plus 1 equals 0. So when we solve them, if we divide both sides by 2 here, cosine theta is equal to 0, and subtract 1 on both sides for the second one, so cosine theta is equal to -1. So cosine tells us we have to look at what?
X.
The x. So where is our x value on the unit circle? 0. Pi over 2 and 3 pi over 2. Perfect. So we're going to say theta equals pi over 2 and 3 pi over 2. Now where is our x value? -1. Pi. Awesome. So we'll add that to our answer list too. So pi over 2, 3 pi over 2, and pi. We're going to ignore B. We're just finding the solutions. Now, this is a little bit different because we have that 3 times theta. So instead of it just being theta, it's going to have something either multiplied or divided to theta. We save that for the very end. So this is the very last step. So we want to do the same thing we were doing before. Isolate our trig function. So what would we need to do first here? Add 1 to move it to the other side, then divide by 2. So 2 times sine of 3 theta is equal to 1. Divide by 2. So sine of 3 theta is equal to 1/2. Sine tells us we have to look for what? Y. So we want to see where our y value is 1/2 on the unit circle. Where is our y value 1/2? Pi over 6 and 5 pi over 6. Perfect. But here for our answer, instead of saying theta equals pi over 6, we have to say 3 theta equals pi over 6. And 3 theta equals 5 pi over 6. Now when we have multiple angles, it's just the very last step that we do is get theta all by itself. How would I get theta all by itself here, Lucas? What do we do? Divide by 3. So dividing by 3 is the same thing as multiplying by 1/3. So then we just multiply straight across. We get pi over 18. We're going to do the same thing with the other one. We divide by 3 or multiply by 1/3, which is the same when we keep change flip. So it would be 5 pi over 18. So these would be our 2 answers. So when you have a multiple angle, when you have something multiplied or divided to that theta, a multiple of an angle, it's the very last step that we do, and it just changes our answer. So don't forget to save that for the end, and don't forget to do it. So we want to get tangent all by itself, and the theta divided by 2 is going to be the very last thing that we do. So what would we need to do first? Add 1. So square root 3 times tangent of theta over 2 is equal to 1. What would we do next?
Square both sides.
Not square both sides. If square root 3 is being multiplied to tangent, how do we move it? Divide both sides by square root 3. So tangent of theta over 2 is equal to 1 over square root 3. Now tangent tells us we have to look at what? Y over x. So when we have tangent, we have to do a little bit of math here. We got to figure out where y over x is 1 over square root 3. So we first figure out the first quadrant, and then we know if it has the same denominator, it's going to be the same value, it just, the sign might be different. So let's find what y over x is in our first quadrant. So 1/2 divided by square root 3 over 2. Keep change flip. So we get 1 over square root 3. Is this what we're looking for? Yeah. So we don't even have to figure out what the other ones are in our first quadrant because we found our answer. So one of our answers is going to be pi over 6. Where else would we have 1 over square root 3? Be careful because 5 pi over 6 would be negative 1 over square root 3 because it's a negative divided by a positive. Awesome. The other one would be 7 pi over 6. This would give us positive 1 over square root 3. So its pair is always going to be the one that's opposite of it. So we have pi over 6. So theta over 2 is equal to pi over 6. And theta over 2 is equal to 7 pi over 6. Now what's the very last step that we need to do? Awesome. Multiply both sides by 2. So we get 2 pi over 6. What does 2 pi over 6 simplify to? Pi over 3. Same thing with the other one. We're going to multiply both sides by 2. So we get 14 pi over 6. What does 14 pi over 6 simplify to? 7 pi over 3. So these would be our 2 answers. So when you have tangent, you want to find what they are in the first quadrant because they're going to repeat in the other ones. So you could just memorize them because the first 3, it's only 3 of them. And the more you do it, like the easier they become. When you divide y over x here, you'll get 1. When you divide y over x here, you'd get square root 3. So you could memorize these 3 or just divide y over x to find what they are in your first quadrant, and then the others will repeat. So if they have the same denominator, it's going to be the same number, but the sign might be different. So one other thing that you'll see in the homework, there's some questions that have our reciprocal functions. So if I had secant theta of 2, which trig function does this one go with? Cosine. So secant is the reciprocal of cosine. So we'd want to flip secant, which also means that we have to flip the other side too. So instead of it being 2, we just make it 1 over 2. So here we just look and see where x is 1/2. So if you're given the reciprocal function, just flip it to the reciprocal where it's either sine, cosine, or tangent, but you also have to flip the number.
It can't be negative.
Like,
Would it be negative?
what do you mean?
'Cause isn't it the reciprocal?
It's not the reciprocal, you're just flipping it. So you're not, like, you're not, I mean, it is the reciprocal, but you're thinking of the opposite reciprocal, which means you have to change the sign too. You're just changing, put it 1 over whatever the number is.